you think of any piece of wood in its simplest form, you can compare it to a bundle of straws. And you take a bundle of straws and you push it or pull it apart, and you'll find that it's very strong parallel to grain. You take that same bundle of straws and you apply a load perpendicular to grain, and it's easily crushed. So you'll want to avoid that perpendicular to grain loading, or at least be aware that it's not the strongest way to load it. And so these products are manufactured with this in mind. We'll begin with our wood structural panels, and we're going to go through these just like the load transfers through a building, starting with our panels to our joists to our beams. So with a plywood panel, you'll notice in this simple drawing that the panel is manufactured by taking a series of plies of wood, laying them up in a strategic fashion, and then gluing them together with moisture-resistant adhesive. So the face and the back have the strong direction of the wood and the long direction of the panel. So you can remind yourself that long equals strong. Secondly, the veneers adjacent to the face and the back are going to be oriented in the opposite direction. By doing so, you're going to be increasing the stiffness of the panel and the dimensional stability. As that panel gets wet, or as wood gets wet, it wants to expand, and dries, contract. So by cross-orienting those veneers next to one another, you're going to therefore increase that dimensional stability. And finally, by using the moisture-resistant glue, that's key to holding it all together and keeping the moisture out. Oriented strand board is manufactured with the same properties in mind. So if you look closely next time you see an OSB panel, you'll notice that the majority of the strands at the face and the back are oriented with their strong direction of the wood and the long direction of the panel. And then the strands in between are oriented in the short direction, again maximizing your stiffness, your dimensional stability, and the same glue is used to tie it all together. So rather than specifying plywood or OSB, we recommend specifying rated sheathing with the proper span rating, thickness, durability that you need, rather than one product or the other, as they are manufactured with the same attributes in mind. Using the generic specification will open up that spec for the widest availability in construction. I mentioned the span rating, and both of these products have a uniform span rating that's applied for the span rating printed on the grade mark. So for our roof span, you see first that the deflection is limited to L over 240, the live load is 30 pounds per square foot, and the dead load is 10 pounds per square foot. For our floor, L over 360 for the deflection, 100 pounds per square foot for the live load, and 10 pounds per square foot for the dead. What is the most common live load that you see for your floor spans? Yes, it can be 100, but more often you're looking at 40 or 50 pounds per square foot. So this is helpful information to be aware of as well, that the span rating that's stamped on the product is based on 100 pounds per square foot live load, which is likely greater than what is needed for your design, most applications. The first framing mistake that I'd like to share with you is installing these panels incorrectly. So as you note on the right-hand side, we have our diagrams showing that the panel needs to be installed in a continuous application. So across at least three supports or two spans as shown here. On our left-hand side, of course, that would be a simply supported installation. And the span rating, in addition to the loading criteria that I showed you in the last slide, is also based on a continuous span loading. So if you have a simply supported span, you're going to be exceeding the design criteria. There are instances, as I mentioned as well, long equals strong is the majority. There are some cases where the strength is oriented in the short direction of the panel, and it will have an arrow designating it in this fashion. Cases where you may see this would be some wall panels that are made specifically for a wall installation. I'll have it labeled with the strength axis in the short direction. Or possibly if you're doing a panelized roof construction where it's a very large roof, they're laying those panels up in the parallel application as shown here where you would have your subpurlins running the length as opposed to perpendicular. And that is done for a specific application. The engineer should be aware of that. So again, you want to, likely they often just still go with this type of panel, but recognize that the span rating that's stamped on the panel is not for that application. So again, coming back to our first framing mistake, you see that if the panels are oriented parallel to the supports as opposed to perpendicular and across multiple supports, it's not going to be meeting our requirements for installation.